There are all different kinds of ways that we can represent data sets. And one of the ways that we can represent a data set is by looking at something called a frequency histogram. Now, some people call them bar charts. It's way more than a bar chart. Some computer programs like Excel or Google Sheets or something that you're going to see from me can do some histogrammy kinds of things. But they're not always perfect and they're not always well labeled, and sometimes they can be really confusing to read. So what I ask you to physically do for me, I will make sure is very well labeled. All right? But what a frequency histogram is going to do, pardon my crooked lines, is it's going to put the values of the data set along your horizontal axis, and then the frequencies along the vertical axis. And even though not all software does it exactly the same as all other software, and sometimes we have to work hard to make our graphs look good and legit, typically what we want is we want our values to be all listed in numerical order on the axis. So let's say I had a data set where the values that came out were just 1, 2, 3, 4, and 5. No other values came from my data set. Now I'm not showing you a data set because I want to focus on the histogram. Now I'm going to draw a histogram. Not the most beautiful frequency histogram I've ever drawn, but this is a pretend frequency histogram for a data set I haven't even shown you. There are 3 things I can get from this histogram, though. 3 statistics, 3 numbers that describe my data. Now, if I'm being good, I will tell you a story about where the data came from. But right now, the story isn't important. It's just all made up. I can tell the minimum value that appears in my data set. Minimum just means smallest. What is the smallest number in my data set? Well, if I put all of the values if I put all the values from my data set along that horizontal axis, I kind of told you right from the start that the minimum value in my data set is 1. If you don't mind, I'm going to abbreviate that MIN for minimum. Can you tell from looking what my maximum value is for my data set? If I really did put all the data values that appeared in my data set on this horizontal axis, which of the numbers on my horizontal axis is the largest, or the maximum, or the biggest? Looks like 5. Oh, you know what? There's another statistic that I can get that I haven't mentioned yet. Something called range. The range of a data set is nothing but the maximum value minus the minimum value. So the range here is 5 minus 1, which is 4. Now be careful. That number 4 that I said is the range has nothing whatsoever to do with that number 4 underneath that rectangle right there. It has nothing to do with the values in my data set, the individual values. All it does is tell me how far apart my min and my max are. So when the range is huge, all I know is I've got a spread out bunch of numbers. Range is a measure of spread. It doesn't tell you what the values were. It just tells you how spread out they are. So when your range is like 80, I mean, the data set could have had values from 100 to 180, or it could have had data values from 0 to 80, or from 20 to 100. You don't know what the data values were if all I say, well, the range is 4. By itself, range is pretty useless. But knowing that the min was 1 and the max was 5, well, those are actual data values. The data value that's the smallest, the data value that's the largest. I'm telling you something about the data values. When I say range, I'm telling you about the spread of my data values. That'll come up again. Now back to the histogram. Not only from the histogram, which is itself a statistic because it's a graph that represents my data. And I didn't tell you what my data set looked like. You can look at that histogram and you can tell me the mode. The mode is the data value that has the highest frequency. So let's step through this histogram, this frequency histogram, and make sure we understand each piece. In a perfect world, your rectangles will be centered around data values. Sometimes when we got lots and lots of data values, you might not center your rectangles. But when we have small data sets, we center our rectangles around individual data values. We're only going to be working with small data sets for a while. The frequency associated with 1 was 3. That means 1 was a data value 3 times. 2 had a frequency of 10. 2 was a data value 10 times. How many times was 3 a data value in my data set? How many times did 3 appear in my data set? Once. How many times did 4 appear in my data set? Once. How many times did 5 appear in my data set? Ooh, 5 times. You know what? I now know my data set. This histogram actually has every single one of my numbers in it without writing out the list of all the numbers. Which means if I felt like it, I could write out my data values. You wanna? Because we can. 1 is a data value 3 times. 2, 5, 6, 7, 8, 9, 10. I write 2 10 times. I write 3 once. I write 4 once. And I write 5 times. Oh my gosh, I was able to look at this histogram and extract my entire data set. That's not always possible because the histograms are sometimes really difficult to read because of the way people choose to label their various axes or not label their various axes, which is very bad. Always label your axes. Always. But when it's well labeled, not only can I look and find the min and the max and then compute the range and look at the tallest rectangle to figure out what my mode is, I can also extract all of my data values. Now, I forgot to tell you what the mode was after I went through all of that, but the mode is the data value with the largest frequency. The mode is the data value that appears most often in the data set. When I look at this histogram and I see 10, or excuse me, when I look at this histogram and I see 2 as the tallest rectangle, and I'm telling you I have a frequency histogram, then I know that 2 is the mode. And with badly labeled histograms, I can still often have a pretty good idea about the mode, the min, the max, and the range of values. Range, again, not so useful right now because range is about spread. It's not about the size of the numbers. Range is about spread. It's not about the individual data values, so it's a little bit different. But a well-labeled histogram, a well-labeled frequency histogram, is going to be one where I can extract or at least get good estimates about what the real data were. And there they all are. How many data values have I got? Well, I could count all the ones that I wrote, or I could say, well, there's 3 plus 10 is 13, plus 1 is 14, plus another 1 is 15, plus 5 is 20. There are 20 numbers. Am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh my gosh. If my frequency histogram is well labeled and easy to read, I will even know that my sample size is 20 in this case, or whatever the sample size is for the histogram that you see. Look at how much information I can get from one graph. Unbelievable. Only when it's well labeled. It hurts my soul when I see published on websites and in newspapers and student research posters and papers. It hurts me when I see a graph that is not well labeled, where I can't extract information from it should I need to do so. The picture ought to tell a story. It shouldn't hide information. It should tell the truth. And it should give the viewer as much information as you think the viewer might need. And so if you decided to take your data and put it into a frequency histogram, then it should be possible for me to make really good guesses, if not perfect matches, for the min, the max, the range, the frequencies, and the mode. And if it's perfect, then I should be able to extract all the data values or estimate them. in which case I could also find the median. If I felt like it, the mean. A really well-labeled, well-drawn frequency histogram should be such that anyone looking at it that understands what they're looking at could reasonably guess or figure out exactly what your data set looked like. A good histogram tells the truth. Now, I haven't talked to you about how to draw a histogram. You might have figured it out by the way that I pulled this one apart and deconstructed it. But what I am going to do is ask you to look at some histograms, not very many, to look at some histograms and do what I just did. Look at the frequency histogram, figure out the minimum, the maximum, maybe the range. I don't know. It's going to depend on how I feel when I type it up. Figure out the mode, or maybe determine if there's more than one mode. Sample size. Sample size. And I'm not going to ask you to write out necessarily. I may or may not ask you to list all the data values, but I may ask you some questions about the data that are represented in the data set in the histogram. Oh, before I forget, grammar lesson. The word data is plural. The word data is plural, meaning that in English, you do not say the data is represented by the histogram. You say the data are represented by the histogram. And you're probably thinking, that sounds wrong. It's not. Data is a plural word. Now, if you get confused and you want to be grammatically correct, then say data set. Data set is about a single thing. Data set is singular. But if you say data and then put a verb after it, subject-verb agreement requires that that verb agree in a plural way. The data are, the data were, not the data is, or the data was. Now, I'll be honest, I mess up all the time when I'm speaking, because I've got kind of a hybrid colloquial thing going on with my language. Yeah, I'll mess up speaking unless I'm doing a professional presentation in front of an audience of people who are going to make fun of me for mixing up my subject-verb agreement. And when I'm writing, I'm ultra careful. But when I'm just talking to y'all, trying to be, but when I am being informal, I'll often mess up and say the data is. But I try to avoid that by saying the data set. So if you're worried about it, say data set. Data is a plural word. And if you're curious, the singular is datum or datum. D-A-T-U-M is Latin. Anyway, we're going to deconstruct some frequency histograms. It's going to be fun. Promise.